Hello ladies and gentlemen, welcome back once more. Today we are talking more about the periodic table. In fact, we'll be elaborating on the previous lesson of the structure of an atom. Today we are very much focusing on this, the periodic table. Now, as you can see below, we have taken helium and we've placed it up in our top corner. All we've done is blown up that box to make it a little bit larger so we can see what's inside there. You can see that there is 2 He, helium, and 4. Of course, it's got 0.003 there, but we are going to ignore that for the moment today. So when we look at our lovely helium atom up in the top corner here, we can sort of start to work out certain elements from it. For instance, that top number there is our atomic number. Now, our atomic number is that one over there, which means, what is our atomic number? Well, 2. Very simply put, it says 2, we know our atomic number is 2. The other number we have down at the bottom is the bigger of the 2 numbers. You will also see that this one sometimes has that decimal place. Like before, we said that there's 0.003 there. Well, we are currently ignoring that, but that's usually a dead giveaway that you're looking at the atomic mass. So in this case, our atomic mass would very much be 4. That number has not changed. Now, that number 2 up in the top also happens to tell us how many protons and electrons we have. Now, I explained this as like a player's card. That tells us how many players are allowed in the field, and that tells us how many players are on the team. Now, the 2 people on the field are our protons and our electrons. That number 2 tells us how many protons we're allowed in the field and how many electrons we're allowed in the field. In this case, both of them would be 2. So we know we've got 2 protons and 2 electrons. The only thing we've now got to work out is our neutrons. But before I said that this number down here tells us how many people are on the team, well, in order to figure that out, we've got to work out how many we have on the field and how many people are on the bench. The way we do that is we take our atomic mass, or our number of team members, and we take that number minus our atomic number. What we are left with is our neutrons, which in this case would be 2. So if we were to put those back where they were, you'll see that our protons for a helium atom are 2, our electrons for a helium atom are 2, our atomic number for helium is 2, our atomic mass is 4, and our neutrons for a helium atom are 2. Now let's try this for one more. This time we're going to look at an oxygen atom, an oxygen over here. All right, you can see the numbers have clearly changed. In fact, it has changed position on our periodic table. We have now moved from there all the way down to here. Now, this number is rather important, so when we break it down like we did just before, that number up on the top tells us the atomic number. So we can put our number 8 next to our atomic number. The bottom number tells us our atomic mass, so we could put a 16 next to it. The protons and electrons are the 2 that are playing on the field, which means I'm allowed 8 players on the field, so each of those teams will have 8 players on the field. So we'll see 8 for my protons, we'll see 8 for my electrons. And when it comes to working out my neutrons are the full team number minus the players on the field. So I will take my 16, I will minus the players on the field, which is my atomic number, which leaves me with 8. So in the case of my oxygen atom, we'll have 8 protons, 8 electrons, 8 is its atomic number, 16 is its atomic mass, and it will have 8 neutrons. 8, 8, 8, 8, and 16. That is a bit of an issue for this diagram though. Because if we were to count like we could have done with the helium atom, we would have found out that, well, this just doesn't work, because in this diagram, we've only got 2 protons, 2 neutrons, and 2 electrons. This is not nearly enough for these numbers. In fact, I would need 6 more protons, I would need 6 more electrons, I would need 6 more neutrons. This brings us to the next topic, because in fact, we are going to focus on this a little bit more differently. So what we do need is to put that one aside and place this one in front of us. Because today we are going to very much look at a Bohr diagram. You will also notice that this diagram has a few more circles than our one before. In fact, our one before was just one single circle. Well, this one is got 3 circles on this one. Now, these circles do get more. These are called shells. And whilst there are more shells, we're only going to really focus on the first 3 today. Now, how do we work out how many shells we have? Well, it all comes down to this. Our periodic table does not just tell us about the individual elements and what their atomic number is and what their atomic mass is, or what their name is, or what their symbol is. It can tell us quite a bit more. In fact, the numbers down here, if we were to place them, would actually help us to figure out how many shells we have. In fact, if you were to take a pen and put 1, 2, 3, 4, 5, 6, and 7, we could put shells on the side. We'll use this for later because it does actually very much help us. Now, before we saw oxygen, that is up on this row. So if I'm looking at this row across, how many shells would I have? 1, 2. It is on the second row. So we would have 2 shells. So in the case of my diagram, that's just below. How many shells would I need? Well, we saw before, we would only need 2 shells. Now, 2 shells for oxygen, well, that's great. But where do I put those other things? For instance, in my other diagram, we had a nucleus. Well, we can take a bit of a shortcut with our nucleus. In fact, we can use the symbol for oxygen, the symbol, and put it in the middle of our diagram. Capital O, that's our symbol. We now know that this circle in here is our nucleus. Inside there we would find the 8 protons, the 8 neutrons, and now all we would have to do is place our 8 electrons. But where do I put these electrons? Well, we kind of have to look back at our periodic table. In that first row, how many elements do we have? We have hydrogen and helium. We have 2 elements. That means for that first shell, we only have 2 spaces, which means there can only be 2 electrons. If I was to go into my second shell, how many elements would we have? Well, we would have 1, 2, 3, 4, 5, 6, 7, 8. We would have 8 elements in that row, which means my second shell is allowed to have 8 electrons. My next shell down is shell number 3. It's allowed 1, 2, 3, 4, 5, 6, 7, 8 as well. There would be 8 electrons allowed to be in my third shell. My fourth shell, there's a few more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So if we were to take a little bit of a shortcut on our lovely table, we could write 2, 8, 8, 18. You will see that a lot of teachers ask you to memorize these numbers. Well, if you do have a periodic table in front of you, you don't need to. You could just focus on these lovely things in front of you. In fact, if we were to take our oxygen atom, that's over there, we would be able to work out how many electrons there are by purely counting across the rows. 1, 2, 3, 4, 5, 6, 7, 8. The atomic number is 8. We know that the atomic number also means how many electrons we have. So how many electrons would I put in the first shell? Well, there would be 2 electrons. How many would I have in my second shell? Well, there would be 1, 2, 3, 4, 5, and 6. Let's place those and see how we go. So here are my lovely electrons. We know that in that first shell, I told you that there is 1 and 2. That's the maximum amount of electrons I'm allowed in my shell. Remember, there's only 2 elements in that row. My next shell had to have 6. So we can place those around. 1, 2, 3, 4, 5, 6. Do we have enough electrons? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8. Our atomic number is 8. We have 8 electrons, and we know that the atomic number equals the same number as we have electrons. Shall we try this for one more? Well, let's have a look. Here we have lithium. Lithium is a different element than we've seen before. In fact, it will have a different number entirely because it's got the number 3 on top there. Well, first thing we would want to figure out is how many of these shells do I need? We'd find lithium right there. We could see that it's in the second row. So how many shells do I need? Well, I need 1 and 2. So 2 shells, 1, 2. Now, if we were to look at the side here, well, let's have a look and try and figure out the numbers we had before. What's the atomic number of this one? Well, that would be 3. We could see it sitting up in the top there. At that lovely number up in the top there is our atomic number. What would be my atomic mass? Well, that would be the number that's down the bottom there. In this case, you could see it's got a decimal. So we would put 6.9. Now my atomic number tells me 2 other numbers, doesn't it? It also tells me how many electrons I have and how many protons I have. In this case, they would be the exact same as that top number there. So I have 3 electrons and I have 3 protons. The other number I need is my neutrons. And my neutrons equals 6.9, or my atomic mass, minus my atomic number, which in this case would give us a neutron count of 3.9. But today we are doing electron shells, also known as electron configuration of the shells. And today we're just focusing on the fact that we have 3 electrons in this one. How do we know we have 3 electrons? Well, we can actually count it if we look at our periodic table. 1, 2, 3. So how many would be in our first shell? Well, our first shell has 1, 2 spots. So in my first shell here, I could put 2 electrons. In my second shell, well, how many would I need? Well, in that second line, I've only got 1 element. So I would only need one electron. In this case, we would have a perfect amount because I would need 3 electrons. That's 1, 2, 3. That inner circle only has 2 spots available. We have filled those 2 spots. And we've got that free floating electron. This electron that floats on the outside is part of what we call an incomplete shell. It hasn't filled all of its spots. In order to fill all of your spots, you would need to make up 8. These are our complete shells. So for shell 1, we would need a complete shell of 2 electrons. For shell 2, we would need a complete shell of 8 electrons. In this case, we only have 1 electron. This electron that we call up here, we actually have a name for it. We call it a valence electron. A valence electron. Now, before we continue with that, let's have a look at one more just so we can make sure that we're absolutely clear on this. Lucky last one, we're going to look at one of my favorite elements, sodium. Now, sodium has 11 as an atomic number. So how many electrons would we have? Well, my electrons and my protons all equal the same as my atomic number, which means all of these would equal the same number, which in this case is 11. All of them equal 11. Now, how could we work out my neutrons? Well, my neutrons require me to know what my atomic mass is. In this case, my atomic mass is that bottom number there, or 23. And my neutrons would equal 23 minus my atomic number, which in this case is 11, which would equal 12. So I would have 12 neutrons. I would have an atomic mass of 23. I would have 11 electrons, 11 protons, and an atomic number of 11. But as I said, we're focusing on our electron configuration shells, so we're going to get rid of the rest of these for a moment and just focus on my electrons. Now, sodium, it has 11 electrons. We can see this on our lovely diagram if we go and find number 11, which is down here. How many shells would I need? Well, let's figure it out. 1, 2, 3. 3 shells. That does mean I need one more shell here. So we'll place that one in the middle. Now we have 3 shells. 1, 2, 3. How many shells would we need for our first, how many electrons would we need for our first shell? Well, let's look at that once more. 1, 2. We can only put 2 electrons on that first shell. 1 and 2. How many would we need on that second shell? Well, lithium is up here and sodium is down here. So it means we would have to go through this entire row before we get down to sodium, which means we need 1, 2, 3, 4, 5, 6, 7, 8. If you used my shortcut, you would know straight away that there are 8 electrons in that row. So we need 8 electrons in this, on this shell. Now how we place them is we place them in 2s. 2 up on that side, 2 up on that side, 2 down the bottom here, and 2 on the side here. Please notice how they're still on that loop. Obviously this is not done because we still have 1 left over. We have now done a complete first shell, 1, 2. We've done a second shell of 1, 2, 3, 4, 5, 6, 7, 8. And now we have 1 more. This 1 is to go in our third shell over there. And that one's out on the side there. So now we can count and see if we got it correct. Well, let's have a look. In that first shell, we've got 1 and 2. In our second shell, we've got 1, 2, 3, 4, 5, 6, 7, 8. And in our last shell, we have 1. If we count them all up, that's 2, 4, 6, 8, 10, 11. 11. Our electron count is 11. So we have done a perfect shell diagram. Or in this case, we call it a Bohr diagram. Give it a try. There's a few on the worksheet. Please give them a go, and I'll talk to you guys later.